awesome. I love hearing about use cases that are, predictive maintenance, obviously, but the more data behind it and just AI in general, it's a very hot topic these days. Um,
Absolutely.
it's also been mentioned that AI can help with sustainability. Could you talk a little bit more on that?
Yeah. So it's clear, I think it's obvious to everyone, right, that if you have algorithms that help to increase your operational equipment efficiency, less outages, more predictable production, for example, it helps reducing waste. Yeah, it helps reducing friction in the process. A process that runs smoothly can always be tuned to produce more output with the given input or to produce the same output but with less input. And one example for that is energy management. Yeah. But another example is simply if the machines are running smoothly, it can't become more efficient than that, right? If you have a frictionless, smoothly operating environment in that regard. That's the obvious part. And companies are leveraging predictive maintenance today, and that's why Senseye is also very popular because everyone is like going for those, I would almost call it low-hanging fruits. The much bigger sustainability topic is really if I can start at product design and use simulation and not only simulate the sustainability footprint of my product, but the sustainability footprint of every related production step. And then choose among thousands of product variants the ones that meet my sustainability goals best, right? And of course, we have this new discipline, and it's a very popular discipline and a very bustling one, which is material science, material discovery, right? In pharma, obviously, drug discovery. But let's make sure that every one of us understands that the principle of what they call discovery is not limited to material and is not limited to drug discovery. The science-based exploration can be done in any industry with any product and should start very early in the process with product design, but not stop at product design, right? And you were asking earlier on a question of how many companies are doing it and, what are obstacles. I would assume, guesstimate, that maybe between 1 and 3% of companies are really looking into design space explorations, but almost none of them is looking into expanding design space exploration from product design into production design, right? And this is, by the way, what we really mean with our vision of digital twins on all stages and also aggregating them into something that we call the industrial metaverse, because that's ultimately using simulation digital twins for products, for production, tying it all together and making the best choices, right, in a data analytical way to have algorithms that help us humans making the best decisions and choices to really minimize the input and the resources that are needed to achieve basically the production of a fine product.
So, industrial metaverse to us is the digital twins from creation of the products of design and the factories. Is that what we're calling?
Exactly. It has two integration directions, right? One is that we don't just simulate production and someone else simulates the product, but we tie this together through the life cycle stages, right? That's one thing. The other thing is, in many cases, companies simulate on a component level. Let's imagine you have an electrical drive, right? And then you have a digital twin of the electrical drive, which is great, in which you, by the way, need to do predictive maintenance for the electrical drive. But the electrical drive is a part of a bigger thing, right? It's a part of a machine. And the machine is part of a production line. And the production line is maybe part of a plant. And the plant is part of a supply chain network of different plants, of different suppliers, all working together to ultimately produce something that that hits, for example, the consumer and makes a difference. And the industrial metaverse is our vision to not stop digital twins and simulation on a component level, but make sure we have a platform that helps us integrating it to the system level, to the plant level, to the supply chain network level, and apply as much simulation and as much algorithmic optimization as we can to reduce the resources that we need to do something properly by factors, say by a factor of 10 overall. And we need to do this as mankind because we really need to transform the way how industry produces. Otherwise, we will be trapped in a future that is everything from what we desire.
So we're using AI in that kind of platform to help optimize people's like plants and parts and
Yeah,
stuff.
yeah, and that is of course related to, yeah, let's take costs out, right? But also to sustainability impact, to energy consumption, to material consumption, to the material footprint that it has at a certain point in time later on, right? Reducing plastics and whatever. You name it. There are so many things that we can simulate, but it's important that we simulate stuff along the life cycle and that we don't simulate stuff on a component level, but we climb up the ladder and look at the system level, at the production line level, plant level, supply chain network level. So we have these two dimensions and endless opportunities, believe me, to optimize.
It's awesome. It sounds like it's all about kind of scalability and allowing humans
Yes.
to become more efficient and scale so we can
Yeah.
produce what's needed for our consumption levels.
And this is what if I may add that, right, what I particularly like with Senseye. Senseye as a predictive maintenance offering has been really designed, not necessarily using the latest and greatest in algorithms, right, all over the place, but it is an offering that has particularly designed to support scalability. And wherever there is human input needed because human input makes more sense than something abstract that an algorithm can provide, then the Sensei architecture included human feedback to make sure that we capture that intelligence in a way that the system can digest it and apply it to other machines as well. So it's not always about having the algorithm that is patented or that is fancier than some other, it's not necessarily the best data scientist. It's how well an offering scales and how easy it can be deployed, and can I embrace the humans in the process and make them part of the project and make them part of the solution rather than a couple of nerdy data scientists scoring with what they believe is the best algorithm. That's not the point for industrial grade AI. It must be robust, reliable, and it must pay into the deployment challenge, right? It must be, scalable and deployable at a large scale.
Yeah, and I think you mentioned that we take a lot of human input for ours, and I think that's something that's also really important for this kind of industrial space because it is humans ultimately running it until we get to the autonomous, machinery. But still, even then, you'd have to still probably have people supervising those machines to make sure they aren't going haywire. Um, but like the human input, I think is also like a super important thing to AI, especially as it's learning.
Yes, indeed.
Um, I guess, is there, how long have we been using the term industrial AI?
I think the term industrial AI is a pretty recent one. And you may remember that we had the North American culture room, so to say, right? Not the North American culture was inventing a term called smart manufacturing.
Hmm.
And then the German machine tool builders and whatnot, they were all coming up with this term industry 4.0, right? That was a very German thing. And what we see a bit is a similar effect. We see the popularity, the very new popularity of industrial AI, and you can look into the analytics of Google search, right? How it's peaking up and so on. That is being driven out of the German speaking community in the first place. So Austria, Switzerland, Germany. And now it's getting really popular everywhere to really talk about the differences between sort of consumer AI or also the AI, algorithms and stuff that are produced by the tech companies, yeah, by the Googles and Nvidias of this world, and then really, separating that great innovation, but from the needs and challenges that are specific to industry. And as I said in my initial statement, there are really specific challenges in terms of how easy you can scale it, and the return on invest is a bit tricky in many cases, and the robustness challenges are not easy to solve, right? And I recently looked at some reporting that we did. We had around 14,000 news articles in magazines and social media last year on industrial AI, right? 14,000 in the 12 months of last year. And we had more than 22,000 in January and February of 2024 alone. So what you can see by simply those numbers, that industrial AI as a term that people talk about, write about, exchange ideas about, that is absolutely peaking as we speak.
So obviously, people are very interested in industrial AI and how it's different than consumer AI.
Exactly, and how to address those many challenges, right? People are actively looking to, connect into ecosystems, find best practices, and really find people who are not ignoring the specific industrial challenges and industry challenges that you need to overcome. It's not super easy. And it's not just using a browser and then getting access to a large language model, and that's it. There's a lot more stuff that needs to be done to really deploy AI in industrial environments at scale. And you can't see many, many companies out there that truly have a track record of deploying industrial AI at scale. Many are still caught in what I would call like this feasibility and lab test phase, right? Many great use cases work perfectly fine in the lab, but as soon as you knock on the first gate of a factory, try to deploy it in real life, wow, you find out you need another project. And then you are happy that you have solved it for one production line. You would like to deploy to the second production line in the same factory. It's another project, right? Not talking about the next factory or not even talking about the next customer with similar machines. Totally different story. And I think that has been quite frustrating also for many practitioners of AI in industry in the past. AI did never scale as a product. It always only scaled as a project. And yes, we see changes, right? We see with the transformer models, the type of neural network architecture that is behind the GPTs of this world. We see the hope, maybe even the promise, that AI starts to scale like a product, not just like a project like in the past. So pretty amazing and interesting times ahead of us, I would say.
I agree. Are there anything else that you'd like to add?
Well, what I can add to that topic, right? Siemens is really the company that tries to take the great pieces of innovation that we see by the tech companies, right? By the Microsofts, OpenAIs, Nvidias of this world, and obviously AWS and Alphabet. And we appreciate that. Although we know it's never industrial grade, right? It's great innovation until it really can hit the shop floor or the product design process, where reliability and robustness is, you cannot compromise on that stuff. So there's a way to go, and Siemens is the catalyst. And we work with those tech companies as our partners. We work with our co-creation customers, right? And form these partnerships to make it digestible, to convert what we find in terms of innovation in AI and make sure it fulfills the requirements on the shop floor and in industrial settings. And that's our mission to drive and make and facilitate industrial AI, industrial grade AI in the ecosystem. And I would simply say, I'd like to send that message. We invite everyone, whether that is academia or whether that is system integrators or whether that is customers or tech companies, to join us in this mission of making AI industrial grade. Final words, so to say.
Perfect. Thank you so much for joining me today.
Has been a pleasure. Thanks for having me, Liz.